Now, for example number 3, we are going to make a graph of the f of x. Okay, so this is the f of x, square root of x minus 2. Now, earlier we introduced the square root graph. Square root graph looks like this. So it's like a half of the parabola. It's going sideways. Okay, so if you still remember from your transformation stuff, all right, if you have a minus 2 next to the x, that means the graph is shifted to the what direction? Right. Okay, so we will shift to the right for 2 units. And we will do the 1, 3, 5, 7, just like the quadratic, but we will do it horizontally. Okay, we'll do it horizontally. So this is our f of x. This is our f of x equals to square root of x minus 2. At this moment, I think we can now go ahead and write down the domain and range of the function. The domain is the x value, and the x value goes from 2 to infinity. And we have the, and it includes the 2. Yeah, includes the value of 2. And then the range is simply 0 to infinity right here. Okay. Now, as we said earlier, you can draw the graph of the inverse then to tell the domain and range, or you may just go ahead and write down the domain and range of the inverse because you know it's going to be swapped. Okay. The domain of f of x will now be the range of the inverse of f. Okay. And then the range would be the range of f of x would now be the domain of the inverse. Okay. So now at the same time, you may also graph the inverse by just looking at the dots right here and then switch the x and y values. You can do that. And we can actually go ahead and do just that right here. Okay. We can do that. So that would be your inverse of f. Okay. And just like what we said earlier, if you have the function and the inverse together on the same pair of axes, they should look like a reflected image over y equals to x. All right, so y equals to x minus 2. And to find the inverse algebraically, we will go ahead and swap the x and y. And then we'll go ahead and square both sides to get rid of the square root. And then we have x squared plus 2, it's equal to y. So our inverse is x squared plus 2. But as you can see from the graph and also the domain, this is not a full-blown parabola. That means we must include a restriction. And in this case, the restriction is going to be x is greater than or equal to 0. Okay, because the part of the graph that we are drawing, it's only x is greater than or equal to 0. So our restrictions, I mean, we have the equation of the inverse, but we must include this thing called the restriction so that people would know how to visualize it and how to draw it, write it. Okay. So that's example number 3. So something new today is to formally introduce the concept of restrictions. Sometimes you may have only part of the graph as your inverse, and we will go ahead and just include that part and that part only.